What is intermolecular forces? And what are the different types of intermolecular forces? And then how it affects to the properties of a substance. Good day! For today's video, pag-aaralan po natin kung ano ang intermolecular forces at paano ito nakakaapekto sa ibang substances. Kung bago ka sa channel na ito, huwag mong kalimutang mag-subscribe at i-hit ang notification bell on. Tara, samahan mo akong panoorin ang video ito. Happy learning! Target on this lesson is to describe the types of intermolecular forces present in a substance and identify the types of intermolecular forces present between and among substances. Now, why do some solid dissolve in water but others do not? What do you think? Why do some solid dissolve in water but some or not? You can type your answer in the comment section. Why? Why are some substances gases at room temperature but others are liquid or solid? Why? Type your answer on the comment section. What gives metal the ability to conduct electricity? And what makes non-metals brittle? What do you think? Type your answers on the comment section. But preferably or generally, it is because of intermolecular forces. There are two types of intermolecular forces or attraction in molecules. The intramolecular bonds and intermolecular bonds. In other words, pag sinabi po nating intermolecular forces, it refers to the attractions within molecules. Attractive forces within molecules. So there are two types of these attractive forces in molecules, the intramolecular and the intermolecular forces. Intramolecular bonds may refer to ionic bond, polar bond, and non-polar bond. So those are intramolecular bonds. Intermolecular forces or IMF have to do with the attraction between molecules or the attraction between atoms in and molecules. Attractions between atoms in molecules. Yun po yung main topic po natin for this lesson. Intermolecular forces come in 6 flavors: ionic, dipole, hydrogen bonding, London forces, and covalent or covalent and metallic bonding or forces. Let's talk about the ionic dipole attractions. We have seen that molecules can have a separation of charge. This happens in both ionic and polar bonds. The greater the energy, the greater the dipoles. Okay? Or the greater the electronegativity, the greater the dipoles. So in both ionic and polar bonds, the greater electronegativity, En is electronegativity, the greater the dipoles. So like example, in this illustration of hydrogen and fluoride bonding, in which the energy, the electronegativity is pulled towards chlorine, which has greater electronegativity. Molecules are attracted to each other. Molecules are attracted to each other in a compound by these positive electrons and negative electron forces. Attracted to each other in compound of positive charges and negative charges or forces. So here you will see positive probably attracts negative, and negative attracts positive. Okay, take a look at that illustration. However, hydrogen bonding is a special type of dipole attraction that is very strong, and it occurs when nitrogen, oxygen, and uh, fluorine are bonded to hydrogen. Kaya nga hydrogen bonding eh. Hydrogen is bonded to nitrogen, oxygen, and fluorine. Tama ba yung fluorine? Now, let's calculate the electronegativity, the change of electronegativity of hydrogen chloride and water. So how could we calculate the change of electronegativity of hydrogen chloride and water? Hydrogen chloride is 2.9 minus 2.1. Hydrogen is 2.9, chlorine is 2.1. So it is 0.8. In water, 3.5 minus 2.1, 3.5 for hydrogen, and 2.1 for oxygen is equal to 1.4. Diba? Dun sa previous lesson po natin, we will just get the difference of the electronegativity of a given compound. The higher the change of electronegativity of nitrogen hydroxide or hydride or hydroxide or oxide and hydrofluoride bonds cause these to be strong forces, about 5 times stronger than the normal dipole-dipole forces. So take note for this 5 times stronger. They are given a special name, a hydrogen bonding, because compounds containing these bonds are important in biological systems. Okay? Hydrogen bonding is a special type of dipole-dipole attraction that is very strong. It usually occurs when nitrogen, tapos na pala yun. In London forces, nonpolar molecules do not have dipoles like polar molecules. How then can nonpolar compounds form solid or liquids? In London forces, which is named after Fritz London, also called van der Waal forces, London forces are due to small dipoles that exist in nonpolar molecules. Because electrons are moving around in atoms, there will be instants when charge around the atoms is not symmetrical. In the resulting tiny dipoles cause attraction between atoms and molecules. Example of London forces is this instantaneous dipole. Okay? Mm-hmm. 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 Take a look at that. Eventually, electrons are situated so that the tiny dipoles form. And another thing is the induced dipole. Look at this, how it will situated. And in here, a dipole forms in one atom or molecules, inducing a dipole in another. Just recall na lang. Okay, let's determine the effects of intermolecular forces on the properties of substances. Ano yung magiging effect ng intermolecular forces sa properties ng substances? Ano ba yung mga properties ng substance? Probably yung ductility, conductivity, etc. etc. Yung melting point, boiling point. So ano magiging epekto nitong intermolecular forces? Alamin po natin. Siyempre, ang target po natin dito sa pangalawang lesson for this, or sa pangalawang, sa part 2 po ng lesson po natin is to identify the intermolecular forces present in each the given substances, and then compare the strength of intermolecular forces in pairs of substance. Predict which among the given substances will exhibit high boiling, melting, and freezing point, viscosity, and surface tension, and solubilities. Then explain the effect of intermolecular forces on the properties of substance. So, of course, states of matter, the basic states of matter, or the fundamental difference between states of matter is the distance between particles, di ba? Yung distance ng particles ng gas looks like this, or as illustrated here. Liquid, the properties of liquid and solid. The total disorder matches empty space. Particles have complete freedom of motion, particles far apart. So the particles of gas can freely move. In liquid, disorder particles or clusters of particles are free to move relative to each other, and but the particles is close together. However, in solid, ordered arrangement, particles are essentially in fixed position, particles close together. So yung changes of states, if you want to change liquid to solid, it is by cooling or compression. Gas to liquid by heat, syempre, or pressure, reduce pressure. Liquid to solid by cooling, solid to liquid, of course, by heating. Because in the solid and liquid states, particles are closer together. We refer to them as condensed phases. Yung particles ng solid and liquid, we refer it as condensed phases. The states or the state a substance is in at a particular temperature and pressure depends on two antagonistic entities, which are the kinetic energy of particles or yung the movement of the particles, how fast it moves, and the strength of the attraction between the particles. Once it collides, how strong the attraction within. Siyempre, since pinag-uusapan po natin yung attraction, may kinalaman po dyan lagi si intermolecular forces, in which the attraction between molecules are not nearly as strong as intramolecular attraction that holds compounds together. Diba kanina, dinefine or previously, dinefine po natin intermolecular from intramolecular. Sa intermolecular, ang tendency niya is to attract. Sa intramolecular, ang tendency niya is to hold forces. Okay, kaya sinasabi po dito, the attraction between molecules are not nearly as strong as in intramolecular attraction that holds compounds together. So, ito po yung covalent bond. Siyempre, since ito po ay intramolecular, yung kanilang attraction is very strong. Pero, pag pinag-collide natin itong dalawa, hydrochloride, ito mangyayari. So, the forces, probably mayroong attraction pero weak. And that is intermolecular force. Or that's how intermolecular force work. They are, however, strong enough to control physical properties such as boiling and melting points, vapor pressure, and viscosities. These intermolecular forces as a group are referred to us as van der Waals forces. Okay? Nabanggit na po natin kanina kung ano yung van der Waals forces or London forces. These intermolecular forces as a group, ulit-ulit. Now, of course, intermolecular forces may affect the physical properties of a substance. Strong attractions between molecules lead to a higher boiling point. Take note for that. Strong attractions between molecules lead to a higher boiling point and melting point and lower vapor pressures. Take a look at this. The different types of intermolecular forces and relative strength. Here is the weakest. Dispersion forces or London forces is the weakest force of intermolecular forces, followed by the dipole-induced dipole, dipole-dipole, hydrogen bonding, and the strongest is ion dipole forces. Just to illustrate this. Viscosity, which is the resistance of liquid to flow, is related to the ease with which molecules can move past each other. Yung viscosity increase with stronger intermolecular forces and decreases with higher temperature. So, take note for that. Yung viscosity, nagre-resist yan ng flow ng liquid. Okay? Kasi lumalapot eh. Pero, ang viscosity, meron siyang stronger molecule forces kapag yung kanyang temperature and decrease with high temperature. Siyempre, kapag may high kasi yung temperature, kapag yung temperature is low, siyempre, ang tendency is mas lalong maging malapot. Pero kapag mataas yung temperature, tendency kasi yung mga molecule particles ay maaring matunaw, kung anumang type of liquid, tendency, magdi-decrease yung kanyang uh, intermolecular forces. Strong ang intermolecular forces in terms of viscosity, pero nagdi-decrease kapag tumataas yung temperature. Yan. In surface tension results from the net inward force experienced by a molecules on the surface of a liquid. So take a look with these examples. Results from the net inward, inside, palabas. So ito po, energy of a system, solid, liquid, gas. So paano yung flow, vaporization, condensation, sublimation, freezing, and melting. So that's how. Wait lang. Yan. Okay. Energy changes associated with changes of state. Energy in heat fusion or heat of fusion, energy required to change a solid at its melting point to a liquid. And heat of vaporization naman requires change a liquid at its boiling point to a gas. Energy changes associated with changes of state. So take a look with the graph. The heat added to the system. Once the heat added to the system at the melting and boiling points goes into pulling the molecules farther apart from each other. And the temperature of the substance does not rise during the phase change. The temperature of the substance does not rise during phase change. Ice change to, when ice melt, you will notice here, hindi nag-change yung kanyang temperature. Paano natin malalaman na nag-change yung temperature niya? Yan, from this point up to this point. From negative 25 to 0. That is solidification. And then, when the ice melts, you will notice naging constant yung kanyang temperature. Pero, nung naging liquid, ito na. Nag-increase yung temperature. Nung yung liquid naging water vapor, you will see here a constant temperature. Kaya ito yung sinasabi dito. Energy changes associated with the change of state. Pag nag-change yung state, during the process, the temperature of the substance does not rise. But then, when that substance form into another substance, when it forms, or after forming, after the phase change, dun lang nagkakaroon ng high change ng temperature. Kaya nga, associated sila. At any temperature, some molecules in a liquid have enough energy to escape. As the temperature rises, the fraction of molecules that have enough energy to escape increases. Okay? Take note for that. Kapag nag-i-increase yung temperature, ang tendency, nagkakaroon din ng enough energy to escape, increase yung mga molecules. As more molecules escape the liquid, the pressure they exert increases. The liquid, the vapor reach a state of dynamic equilibrium, liquid molecules evaporate and vapor molecules condense at the same rate. The boiling point of a liquid is the temperature at which its vapor pressure equals to atmospheric pressure. And the normal boiling point is the temperature at which vapor pressure is 760 torr. Okay? So much for that. For now, for week 3. Happy learning. Thank you for watching. Another important lessons for physical science, and hopefully nakatulong po ito sa ating mga grade 11 distance learners who are taking physical science. And don't forget to subscribe and hit the notification bell on, and like, comment if you have relatives, friends who are having the subject physical science for grade 11. Share this video to their group chats or Facebooks para makatulong po ito. Lalo na po ngayon, enhanced community quarantine. Okay? Thank you for watching. Happy learning, everyone. Bye-bye. Thank you.